Hi, welcome to the second session of Witness introduction that you will see in this second week. I hope that you have enjoyed the first session when we just learned to connect with the main elements. This week, we're going to learn a few additional things, especially how we can include a label, which is very important, especially once we want to run aspect regarding to capacity and especially to visualize the state um, dynamically, but also in the report, which means that we will see how an element has been busy, idle, waiting for part, or waiting for a label, which is very important to understand, especially once we are analyzing bottlenecks, throughput, efficiencies. The model that we're going to use here is very simple, as we can see here. So basically, it's an upper A1, which is pushed to buffer B1, and then machine M1 pull that part from B1, and M1 push directly to M2. So we're going to create this model very quickly, as you already know, considering the drag and drop approach. So basically, we drag a part, then we drag a buffer, then we have a machine, and then we have another machine, which is here. So this is very quickly. Now, by right-clicking over every element, this is A1. Now this is B1. This is M1. Sorry, this is M1. And this is M2. As you notice, there were a mistake in the one error. Is because Witness is very precise in terms of the way in how you can name elements, and all of them should start with a letter at least. I mean, they cannot start with a number, as you saw in the previous lab session, and then also they cannot have special symbols. So here from this slide, we know that every part arrives every 6 minutes at the minute 6. So this is an active part. Oops, sorry, it's an active part arrive at 6 and then every 6 minutes. Then buffer is a capacity of 1,000 units, which is here. Then we have a machine which has a cycle time of 4 minutes. Then M2 has a cycle time of 2 minutes. As we remember, in order to see the units of this model, we need to go to clock and then click on minutes, so we can be sure that all the cycle times, arrival time, all the cycle times in terms of time, of course, are in minutes. Then we know that A1 is pushed to B1, so we have to use the same aspect like we did in lab session 1. Then M1 pull from B1 and M1 push to M2. Then finally M2 push to ship. Just click on ship. So as we can see here, the model is clearly done. Of course, we can see if what we said is correct. I mean, if the part are going to follow the sequence that we have set. And then to do so, as you know, we go to View, Element Flow, click on OK, and that's it. So basically, we are saying that this is the sequence that we're going to follow. Then, basically, as you know, all the rules were set already in Witness. So this is pretty simple. You can see that basically it's pushed to B1, A1, where M1 just pull from B1 and then push to M2, and then M2 just wait for part, and when it's finalized, push to ship. So the process is very simple. We can see how it works if we model that something quickly. So we can see that parts are going through the system, so the model is working well. So then what we can do, for instance, if you want, we can change some icons. This is very simple, just by right-clicking the element, we click here in this icon so we can set a different figure. Just to follow the slides of the example, let me see if I can find the same ones. All the time, sometimes depend on the version. This one is this one, and that one is this other one. Let me see. So I think that I try, if I'm not wrong, it's very similar to, let me see, is I think I should find it. Sometimes it's not that simple. I think that is this one. Yeah. Now for the part also I use another element. So I'm going to display a different icon that's going to help us with this. So I'm going to use in particular this one. So now that we see the model flowing, we can see that a part with more sense is going through the system. Now please notice that the part is kind of a turning once it's moving. So in case I don't want the part to turn, I just need to go to update graphic, and I just need to unclick the auto rotate. So I click on update. Then now we will see that the part will flow as it is. You see, so it doesn't need to rotate, which is just a graphical element. So this is more or less the same result that we should get once we run the model 1000 minutes. So we're going to put 1000 minutes. If we want to run this very quickly, we just need to click on the bell. We click here in the batch mode. So eventually it's just run 1000 minutes. We need to see the report, the statistics, and then we can see that we got more or less the same results. So which is correct. Now, what is interesting is that we can see the chart state for this machine, which means that we know how much time the part has been busy and how much the time the machine has been waiting for parts or has been idle, which is very relevant. Also, you know that we can display those states by going to view, keys, machine, draw, and then we click anywhere here. So then we can know more or less the states. Still, if we can make this smaller, we can change the font, for instance, make it. Now it's 8, we can make it even smaller, like a 5, for instance. Put OK, we update. Now this looks much more smaller, so which is more compatible with the size of our model. Now, let's see here. We follow this. So now the idea is try to analyze the elements model state behavior for. So we try different cycle times. So the idea of this is that you play with the cycle times and you also try different time of arrival. So the idea is that you shall compare how the state evolves by doing so. For instance, if we do, let's say, a scenario 8, for instance, which means that part inter-arrival time is every 10. So inter-arrival time is every 10. So we put here 10. Then machine cycle time is 4. This is the same. And then machine cycle time 2 is 7. So once we run the model 1000 minutes, we put that like this. So we should expect, probably a different type of behavior. So you see the model runs is still fast, but again, doing the batch mode is very likely to do once you know that the model is working correctly. So then you want to run the model faster. So then we see the statistics. So then we can see, for instance, what did happen to the model in this case. So you can compare how much busy was every part and was not. So I'm going to put exactly how it was. So this was every 6. This cycle time was 4, and this one was 2. Okay. So then the next part is about we can add a label, which means that now the part will depend on the label that is there. So we're going to just drag and drop a label. We're just going to name it as a label 1. And basically what we need to do is that in every machine, whenever a part arrives, we need a label to move. Once it's finished, the part was going to use a label in every machine. So in this case, in this example, we're going to use the same label. So labor 1 is going to use, in this case, labor 1. So we can either write it as here, as we are saying here, labor 1. And if this is correct, we click on validate and it's correct. Or either we can double click over the labor element. Once we have here labor rule, instead of just writing it, we delete this and then we double click over this element here and immediately is written correctly. This is particularly useful, especially once you deal with several type of names and you don't want to make mistakes. That is particularly helpful. So then the idea is that we can, in the same way, we can run the model and see how it works with a labor. So we can run the model. We can see that the labor is working pretty fast. I can delete, I can reduce the speed so we can see what happens, you know. So clearly a labor is being used. So we can run this model more quickly to wait the 1000 minutes. So the idea is that you may try the different previous scenarios to see how busy or how complicated the labor is by dealing with all these different tasks. So now the model finished. I can try to see some statistics as well again. So let's see what happened with the labor. So the labor, as you can see, is almost all the time busy, just is because, of course, we have only one labor. But what is very interesting here is that you may, for instance, you may right click on here and you can add the number of labors available, let's say 4. See, and I'm going to run the same model. So by having 4 labors, we'll see what happens. I'm going to run this model very quickly. Now it's run. So here I'm going to see the statistics now. I will go directly to the labor here, right? And then here I will sub rows and columns, right? I will look at the daily report, right? And then I will click group jobs. So I will try to see, sorry, I'm going to look to individual first. So of course, when I see the individual and I click on chart state, we can see that the labor 1 was pretty busy where the other 2 were not that busy. So probably with this, we are saying that we only need 1 labor to commit with all the different tasks. I don't know. This is different strategies. There are different strategies that you may try once you run the model. So let's put this again in 1. So this is, you can see that this feature is very interesting in Witness because you can try a lot of activities. So try to run all the different scenarios and all the different activities, and then what is something that could be very interesting for you is that, for instance, if you try another scenario, let's say, for instance, this one, right? So what is very interesting, try to generate your own report. So you go to statistics, for instance, and then you see, for instance, the 2 machines like this one. So interestingly, you can copy this, for instance, by marking this. You can just copy this, for instance, and you can use, let's say, any Excel. You have Excel available. Ideally, you may try to see if I can open this. Yeah. So you can just copy paste, you know, the table, and then you can have a scenario 1, a scenario 2, a scenario 3, and then try to compare how the different result works. So with this, this is more or less all the introduction. So the key thing of this particular exercise for today is that you need to learn to collect data. So try all the scenarios, try all the possibilities, try to understand how the labor is busy or not busy. Try to understand how every machine is really depending on the labor, and trying to see if you find any additional state, for instance, any other of those colors, right? And trying to identify where also is a bottleneck. So I hope that you like this session. And again, for any question, Daniel, Shatai, and myself are going to be more than happy to support you with this.